Alright, in this video we're going to try to understand the difference between factors and multiples, and once we can do that, we're going to see how you can show the factors of a number. So let's take a look at our first example. Here we have the number 12. I have two things I'm going to try to do here. I'm going to find the multiples of 12, and then I'm going to find the factors of 12. Now, we've probably heard the word multiples quite a bit when we learn about our multiplication tables and when we multiply numbers. That's where multiples comes into. So if you think of all the numbers that you can multiply, the times tables of 12, like 12 times 1, 12 times 2, 12 times 3, we end up getting 12, 24, 36, 48, 60, 72, 84, 96, and I can keep going on. I can go on forever because you can just keep adding 12 and making the number bigger and bigger and bigger and bigger. These right here are your multiples of 12. All of them are bigger than 12 because it's 12 times 1, 12 times 2, 12 multiplied by 3, 12 multiplied by 4, 12 multiplied by 5. Multiples is when you're multiplying that number to get bigger numbers. So you might be wondering, well, what's a factor then, if that's what a multiple is? A factor is going to be numbers that you multiply together to get 12. So if I said, what's some numbers you can multiply to get together to get 12? Well, easiest is going to be 1 and 12. I can multiply the numbers 1 and 12 together to get 12. What else can you multiply to get 12? Let's say 2 times 6 gives me 12. So 2 and 6 are multiples of 12, or factors of 12. What else can you multiply to get 12? Let's just say 3 times 4. 3 times 4. So these, since you guys can take these numbers and when you times them together and multiply them together, you get 12. We call these factors. Each one of these is one factor of 12. So if I said, what are the multiples of 12? 12, 24, 36, 48, 60. But what are the factors of 12? 1, 12, 2, 6, 3, and 4. Those are all the numbers that I know can go into 12. There's no more numbers that can go evenly into 12. So if you ever kind of get them confused, the way you can think of it is multiples. Since we can go on forever with multiples, we have many multiples. But with factors, you can't go on forever because these are the only numbers that I can multiply together to get 12. So I'm going to say with factors, we have few factors. Now some numbers are going to have a lot of factors, but they're not going to have as many factors as there are multiples. You can have an infinite amount of multiples, but you can't have an infinite amount of factors. So let's see how we can organize and understand these factors a little bit more now that we know the difference between that and multiples. So here what I'm trying to do is I'm trying to find the factors of 24. And one of the methods we can use is called a t-chart. And the reason they call it t-chart is because it looks like a big old T. I'm going to put the number that I'm trying to find the factors of, which is 24, up here. Instead of just kind of randomly putting them in like we did in the last one, we're going to try to organize them a little bit. Every number has at least the factor of 1 because you can always multiply a number by 1 to get that number. So on the left side you think, okay, 1 times what gives me 24? Well, I know 1 times 24 gives me 24. And then I'm going to think, okay, can the number 2 go into 24? Well, it ends in 4, so I think the number 2 can go into 24. 2 times 12, if I remember my multiplication tables, that's right. 2 times 12 gives me 24. What about 3? I think 3 times 8 will go into 24, or 3 times 8 gives me 24, so these are two more factors. Will 4 go into it? Yeah, 4 times 6 will go and will make 24, so those are two more factors. 5 doesn't. I know 5 can go into 25, but not 24 evenly. 6, I can go 6 times 4, but okay, what I just realized, I'm starting to repeat myself. I just did 6 over here and 4 over here. And if I kept going, I would see 7 doesn't go into it, but 8, I would say 8 times 3. I've been repeating myself now. So once you start saying that you're repeating yourself in the t-chart, you're done. You finished it. You found all the factors that you need to. You don't need to repeat yourself. Okay, so each one of these by itself is a factor. Like let's say, I'm just going to circle the number 6, and I'm going to say 1 factor. But when I put them together, like 3 times 8, or 2 times 12, or 1 times 24, we call that a factor pair. Factor pair, because we have a pair of them. We have two of them together that we have to multiply to get 24. So a factor pair, and then each one by itself is like a factor, like a pair of shoes. You have one shoe, but when you put them together, you have a pair of shoes. And you might be thinking, well, what's this pairs thing over here? This pairs thing, sometimes you'll see like 1 and 24, you'll see it written, the factor pair written like that. Another factor pair for 24 would be 2 times 12. Another factor pair is 3 times 8. And this kind of looks like when you do the coordinates, but it's not meant for the coordinates where you make the on the grid. And 4 times 6 is another factor pair. So here's another way that you'll see them written sometimes. Let's see, area model. The area model is another way that we can understand the factors. If I take my first factor pair, 1 times 24, let's think of an array. An array and an area model, those mean the same thing. 1 times 24, and we don't have to draw all 24 little lines in here. As long as we have the number there, that's fine. 2 times 12, so a little bit bigger. 2 times 12. 2 times 12. 3 times 8 would be another one. This is a lot better on graph paper, but you get the general idea when I draw it like this. 3 times 8. 3 times 8, and 4 times 6. 4 times 6. 4 times 6. And I could draw another one where it was 8 long and 3 wide, but I'll just go ahead and keep them like this, and they can turn either way. But these are area models. Just think of area. We call it an area model because when you find the area of something, it's length times width. But you can also think of this as a, that's right, multiplication array. Multiplication array. And our final one, our rainbow list, is where we basically take these numbers, but we put them in some kind of a list order. So I'm going to put them in order from lowest to greatest. 1, 2, 3, 4, 6, 8, 12, and 24. And I just went down this way, went across, and went up this way. And they call it a rainbow list because what you can do is say, okay, 1 times 24 gives me 24. 2 times 12 gives me 24. 3 times 8 gives me 24. And 4 times 6 gives me 24. You can make this list without making the little rainbow things on there, but they call it a rainbow list because you can connect them. So these are 4 different ways that you can show the factors of a number. I prefer the T-chart myself. I usually draw a T-chart, and then I make the list underneath the T-chart from lowest to greatest to give me 2 different ways to look at it. But let's take a look at a couple more different types of problems to see how factoring helps us in other kinds of math.